Okay. Has anyone ever heard the phrase dimensional analysis before? One-ish, maybe two. Did you guys ever have you guys ever heard of the phrase conversion factor? You have. No one else. Okay, well, now I know where we all are. Now I know where to start. Okay. This technique, dimensional analysis, is something that Mr. Homan and I have been teaching, well, as long as I've been around, and as long as Mr. Homan's been around, and Mrs. Cotty, everybody know Mrs. Cotty, another chemistry teacher, also teaches the same technique. I believe Mr. Borzon, does anyone have Mr. Borzon? Also uses a similar technique. The reason we all use this technique is because, one, it's incredibly efficient, and that means it allows you to get problem solved quickly, and it's also highly effective, which means it gets you the right answer. And we want both of those things, quick and right. All right? The other reason we like this is because, as it turns out, most of our students, I'm going to say most, a large majority of our students is able to learn this relatively quickly. The few students that aren't able to, it's not really the technique that's bothering them. They usually have other factors that are limiting their ability to do this, meaning they're not very good at math. They don't know what the difference between the numerator and the denominator is. And if you don't know that, then yeah, this is going to be a problem. Okay? So the actual process they could learn if they knew what that meant. So anyway, dimensional analysis uses something called a conversion factor. Okay? It's going to help us set up the problem, these conversion factors. I'll just give you a really simple example. When I do the example, a lot of you are going to go, oh yeah, I did this back in physical science. Seriously, you will. So if I say, I'll start with something really easy. Here's an example of a conversion factor. Let's say we have 17.38 millimeters, and I want to convert that to meters. You guys ever do this before? Okay. How do you convert 17.38 millimeters to meters? Well, you always start with what you're given, in this case, the millimeters. Does anyone know directly how to get from millimeters to meters? And you might. David? No. Don't give me an operation yet. Tell me what value, what the relationship is. Your relationship was wrong also. So we'll do it this way. Does anyone know how to go from millimeters to centimeters? What's that? I don't do that. Oh gosh, we have trouble with the metric system, don't we? You're going to find out here really, really soon that you actually know the metric system better than you know the US system. I'll prove that, but we'll wait for that. Yes. No, we're not going to do that. You'll see why here in a little bit. Yes. What's the relationship between a millimeter and a meter? What does the prefix milli mean?
Isn't it like 10 millimeters?
That is true. Does anybody know the yes? No, it does not. Okay. Let me help you out here. How many years are in a decade? 10. Deca means 10. Deci means 1/10. How many years in a century? 100. Centi means 100th. How many years in a millennium? 1,000. Milli means 1,000. You see where I'm going with this? These are words that you guys are familiar with. There are 1,000 millimeters in 1 meter. Okay. Now, since these two things were equivalent to each other, I can make a conversion factor. I can make two different conversion factors out of them. I can either put 1,000 millimeters over 1 meter, or 1 meter over 1,000 millimeters. So it depends on what information I'm given and what I'm going to find out, which one of these two I'm going to use. In this case, I'm given millimeters. I want to end up in meters. So I'm going to pick the one in which the term I'm looking for ends up in the numerator. What you're looking for goes in the numerator. So, 1 meter over 1,000 millimeters. Where is this 17.38 millimeters? Is it in the numerator or denominator? It's in the numerator. Is there anything above it? No, so it's in the numerator. It's an understood one, but it's in the numerator. Where is the meter? Numerator. Where's the millimeter? Denominator. So if we have terms that are in the millimeter or in the numerator and the denominator, they cancel out. Would you agree? Okay, what are we left with unit-wise? Meter. Is that what we're trying to find? Yes. Now we just do the math. What math would we do on our calculators? What would we do to find the answer? 1738.38 divided by 1,000, wouldn't we? Isn't the 1,000 in the denominator? Would we then not divide? Okay, so 17.38 divided by 1,000. Yes. Everything that's in the numerator gets multiplied, everything that's in the denominator gets divided. How many of you have seen and or done this before? Most of you. Most of you. Okay. Next, let's try a little bit. Step it up a little bit. .38 milliliters to gallons. No, let's not do gallons. That would be silly. Let's go to ounces. Does anyone know that direct relationship? Turns out I do, but that's okay. Most of you don't. So how can I get there? Well, we already know that we can go from milliliters to liters. We've done that. Does anybody know the relationship between liters and ounces? Yes? What is the numerical relationship between liters and ounces? You don't know that one, yeah?
Isn't there 32 ounces in a liter?
No. Because they're two different systems of measurement. Okay. I happen to know the relationship between liters and gallons. As it turns out, many of you do too. No, it's not. But no, it's not. It's okay. And then, does anybody know the relationship between gallons and ounces? So we went from the metric system to the US system. Yeah? No. 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 No.
Where's the gallon?
Yes. Okay. Does anyone know how to go from gallons to quarts? Oh, there we got one. 4 quarts per gallon. Does anyone know how to go from quarts to ounces? No. No. It's 32. What? This is all this is the U.S. system. Remember, you guys don't know the metric system. You know this system. Oh, wait, no you don't. Okay, so here we go. We're going to use this path. So, 17.38 milliliters. Can we go from milliliters to liters? Yeah, we just did that. 1,000 milliliters, 1 liter. How do you get from liters to gallons? Well, as it turns out, this is the one I said that many of you know. Has anyone ever had milk before? Where do you get your milk? From what type of container? A gallon container. Have you ever read this container? Every single one of you has access to this information. Have you ever read the label where it said 1 gallon? And right next to it in parentheses it says 3.78 liters. So guess what 1 gallon is equivalent to? 3.78 liters. Young men in this classroom, have you ever used a urinal? You also have access to this information. Because right on top of the urinal it says 1 gallon per flush. And then in parentheses it says 3.78 gallons per liters per flush. Yes. You are facing in the wrong direction, so you'll never see that. Go ahead.
So will you tell us?
Oh no. I'm going to tell you the ones you need to know. Yes.
So we don't have to memorize.
Oh yes, you absolutely do. Here we go. So now, we've got, we just got done saying that there's 3.78 liters in 1 gallon. Which of those am I going to put in the numerator? What am I trying to find? I'm trying to find gallons, so that goes in the numerator. Liters gone. Now I'm trying to get from gallons to quarts. As someone said earlier, there are 4 quarts in 1 gallon. What goes in the numerator? The quart. So that my gallon cancels out. Now I need to go from quarts to ounces. I just said this number. Anyone remember? There are 32 ounces in 1 quart. Which of those goes in the numerator? The ounces. That's what we're trying to find. And there we go. We let the units tell us how to set up the problem. Dimensional analysis. That's a little bit amount of work. We're going to do things that long constantly all year long. Now we need to get you guys to get this into your calculators and give us the right answer, which is a whole nother can of worms, by the way. One would think that simple multiplication and division by now at this point in your careers would be pretty easy. Turns out, in some cases, not so much. So let's see what you guys get. Here's my estimate. Might be off a little bit. Let me read you. Anybody use the parentheses? Good. I'm using it. Unless you have to. I mean, I've been sniffing to have to do it. All right, anybody have a number they'd like to throw out? Allie has one. What do you got? Point what? 0.58. What do you have? Okay. So we're around 0.58. Anybody else around 0.58? A number of you. Okay, that's pretty darn close to 0.6, isn't it? All right, here's what I would do on your calculators if I were you. How much time do I have? Okay, it's all multiplication and division. It doesn't matter the order that you do it in. You can do this. Divide, multiply, multiply. Multiply, 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 divide, divide. Divide, divide, multiply and multiply. Doesn't matter the order you do them in. However, if it's in the denominator, you have to divide. If it's in the numerator, you have to multiply. 0.58, everyone pretty much happy with that one? Now, we actually need 4 significant figures, so what does it turn out to be? 0.5 what? 5. So it would be 0.58. There you go. Okay, your assignment is nothing to do with that.